All right. Hey, everyone. It's Wednesday. It's time for the Hangout. Welcome, everyone, for joining us live and those on YouTube. We are celebrating our 1,000th subscriber show today. So everyone here in the group is going to get a pat on the back later on. I've decided to do a little something with it. I got some feedback from people both in our group and also out on YouTube that sometimes us nerds get really deep and we lose some people. So today I am going to try my best, and I've already talked with Pat to see if we can together and collectively keep an eye on everything to make sure we are 100% top level. The plan is this channel is supposed to be for education and entertainment about meteorites and space exploration. And I don't want to lose anyone. And I don't want anyone to feel intimidated to ask questions. So this week we're starting a new weekly segment on the show, and that is Meteorite 101 class. So each week we're going to have a very small, digestible, introductory newbie Meteorite 101 class. And that's a time when throughout the show, anyone can ask any questions they ever can think of. And yeah, we just want to make this as interactive as possible. I don't know if I mentioned the date or not. It's March 10th, and that's important because we're going to talk about some fresh falls. All right, so here's kind of the agenda for today. We have an update on the witnessed meteor from the UK last week. It was found, so a really exciting update on what they found. Also, the first ever witnessed meteor in Vermont. I used to live in Vermont for 5 years, and this thing would have went right over my head. So I'm super excited about this one. The information we have thinks there's rocks on the ground. We're going to have our quick Mars update as always. Maybe not that much information today, but we're really going to spend some good time on the Meteorite 101 class. I think that's going to be something for everyone to really enjoy. And we'll show you how complex meteoritics is and why we're taking a little bite of the apple each week for as long as it takes. Marko's checking in with a video from Germany, and our Belgian friend Maxime is going to be visiting Ganymede on this week's tour of the universe. And I decided not to designate a whole show towards eBay fakers, but each week we're going to have an eBay faker of the week. If we all target one person, we can get that person shut down. Last week we were quite effective. So this right now is about the UK fall. This is the one we watched last week, going through Orion and fragmenting as it goes.
That was a long burn.
Yeah, it's beautiful. So these are the actual videos that were captured of the fall.
God bless the people making those Ring doorbell cameras. We have 4 video of meteors from those things.
Yeah, and dash cams too. Dash cams in Russia.
In Russia, yes.
Yeah. So I can remove the spotlight off of me real quick. Okay, so I don't know what the name of the meteorite's going to be. Winchcombe, perhaps. That's kind of where some pieces fell. But this is the meteor that was seen in the sky on February 28th, and they actually found chunks of it. If you look at what we have here on the ground, Pat's going to explain a little later on why that meteorite that hit the driveway does not look like any meteorite we have in our collections necessarily. Why did it fragment? Why did it just fall apart like that? And there's a big clue in there because it's the Earth's newest carbonaceous.
Carbonaceous, yeah.
Yeah. So the fact that it's carbonaceous lends it to break down, but we're going to explain how and why. We're not going to take anything for granted. I didn't know this when I was building the slide deck, but the anonymous driveway owners have now come forward. And I have an interview with, I didn't interview them, but BBC or someone interviewed them And let me see here. So these are some of the pieces that were found.
Nice.
And they're gorgeously crusted. And I'm going to put Luke on the spot because Luke booked a half-hour personal shopping experience with me online, and it was a half-hour shopping experience. We ended up spending 3.5 hours on the line, video chatting with each other. When all said and done, I think $20 was spent, but I have a new friend, and I'm going to test to see if that 3.5 hours paid off. Luke, you are now on the spot because this is the question you asked, and I explained it to you. So I hate to put you on the spot, but that's what I love to do.
Well, hopefully I don't get it too wrong.
No, we're staying so top level today, buddy.
Okay.
Why is that guy pointing at the piece, and why is that piece on aluminum foil?
Because they use aluminum foil to pick up new meteorites to prevent any type of contamination of the meteorite. The aluminum foil is intended to be non-contaminaminating to new meteorites.
Look at that.
Well
we have a new genius at the bar. Exactly. Especially super especially with carbonaceous meteorites. Again, staying high level. Carbonaceous meteorites, as you can see, are different than stony meteorites or iron meteorites. They're very friable. They're very fragile at times, and you saw that one hit the driveway and basically explode. They have the possibility, because they're carbonaceous, to have amino acids and chemicals and good scientific stuff that science wants without your finger and your DNA and your sweat and your salts all over it. Pat, you want to add to that, or is that?
Yeah, that's absolutely just spot on. So in part of our theme for today is keep it simple, and I love the word friable. I use it as often as I can, but it's basically a $10 word to say crumbly. These carbonaceous chondrites, and so far, you know, for the peanut gallery, we're all guessing what the classification might be. But I think a wise man might consider CM2, which is the same as Murchison and a few other very famous ones.
Yep.
And
scientifically important ones.
Absolutely. Topper is completely spot on that these contain amino acids and all sorts of carbon-based compounds. And carbonaceous chondrites, especially of this sort of class, contain water. And through a bunch of fancy stable oxygen isotope stuff that we can talk about sometime, the water that comes out of these carbonaceous chondrites, and that's why there's all the big cracks and shrinkage going on there, is the water's coming out. Mm-hmm. The water in these things is the same as water on Earth in these oxygen isotope ratios, and so this could very well be the way that life spreads around the cosmos. And Sean Mahoney said it very well the other day on one of our meteorite chat things. He calls these things a cosmic stock cube. So
that's awesome. Like a bouillon cube for life.
Right.
Yeah, nice.
So you know, these things have amino acids. The Murchison is found to have an AC base pair. And DNA is self-assembling, and the only other thing you need is liquid water. So this is life in a rock. Now, it's abiotic. It's pre-life, but it's all the building blocks for life in a rock.
So we have what it takes, at least. So that's one of the main reasons, especially with carbonaceous meteorites, why they are so collected scientifically.
To think that a piece of rock billions of years old has decided to land in our little town, I think is wonderful, really. It's got everybody talking about it.
I just heard what sounded like a photo frame falling down, thought nothing of it, until the following morning, where there was a sort of black splatter on the drive.
The pieces looked very dark, very kind of jet black. So when we came out later, we had a good scrutiny of it and thought, gosh, this is something special. And then that's when Rob came out.
I sent something out to my son on the WhatsApp, and he came back saying there are reports of fireballs in the area, and it seemed pretty certain to me that those two things were linked. And then after that, I was pretty sure that I was dealing with something from outer space.
Did you notice he couldn't even stop smiling when he was saying that?
It blows your mind.
From outer space. I was pretty sure that I was dealing with something from outer space.
Love it.
It blows your mind to think that this is from before the universe started. Yes. We've sort of lived a very, very sheltered lockdown life for the past year, and then all of a sudden something so rare turns up on your driveway.
Scientists tell us it's 4.567 billion years old, and you can't imagine the magnitude of that. But it's a wonderful experience, wonderful to think it's come into little Winchcombe.
Now that I know that they have been found, I might start looking. Yes, I could frame it and put it on the wall.
It'd be nice to find someone, even if I didn't recognise what it was, you know. But anything that puts the town on the map, so to speak, is good for the town.
That's awesome, isn't it? Just this small little UK town, and like I said, they're on. Hold on.
To think that
they're on lockdown right now. So everyone's just sitting there bored out of their skull, and all of a sudden the universe just drops magic on their laps. They actually came out and found that in the morning. They had it isolated and made it as a donation to a university. So
yeah, the Natural History Museum has most all of the material, which is great for science. Kind of a bummer for us collectors, but great for science. Here is, I don't know.
Now, something that falls in the UK laws say that if it's an important meteorite with significance, it goes to the crown.
Well, that's a really interesting question, and there's some controversy about that right now. We just got an answer from one of our UK collectors who said that, you know, if it falls on your place, it's yours. If it falls in the road, you can go pick it up. Which is similar to our laws in the US, where meteorites are considered to be of the land. But my understanding was that for that stuff in the UK, that they belong to the crown. So more to be heard from that.
Absolutely.
Topper, if you want to switch real quick over to my camera.
Okay. What's that, Pat?
So this is a piece of Murchison, and which is a CM2. And so far from the peanut gallery, we're guessing that that this new UK meteorite is a CM2. But this is where your amino acids and your carbon compounds and all that good kind of stuff comes from. So this is scientifically, this is a very important meteorite. The majority of the stuff on the ground has gone to the Natural History Museum, and will be studied there. I'm sure there's a headlong rush right now to get this baby classified and in the books. But this is a fabulous success. There's a bunch of the people in our meteorite community who have assembled a fireball camera over the UK, and this is actually the first recovery in 30 years in the UK, and they couldn't have picked a better one. Yeah. Better type.
A nice carbonaceous. Yeah, I'm super pumped about that. And you know, we have a few of our fans over there in our meteorite, not our immediate meteorite crew, but our meteorite family are over in the UK. So I'm hoping that they were able to get some of that. But this one here, this one has my attention. This just happened over Vermont, and this video was actually captured by the Burlington. By the Burlington airport. So this was like 5 minutes from where I used to live.
And Topher, while you're firing that up, those videos are really important too. Not only about where it's going to land, but also they can actually backtrack when they get enough of those videos, what the orbit was.
Absolutely.
For where this thing came in from.
Mm-hmm.
Yeah, and back in the day, there was a famous illustration in the textbooks of the 6 meteorites that we had some crude guess of their orbit. Now there's dozens, maybe hundreds.
That second video gives me a lot more confidence about stones on the ground than the airport one.
Yeah.
The airport one, I saw that one, and initially I was thinking it was so fast and such a sharp, not a sharp trajectory, but a long trajectory, that it would make me believe that it was gonna just blow to pieces.
Yeah, and this is at 5:30 p.m. So it's still bright. I mean, that's a bright bolide for 5:30 at night. It's going into the sunset and you can still see it. Yeah, so I don't really have any I don't have any problem believing that there's pieces on the ground, because if you look at this state, this is for our we have a lot of Moroccan viewers. So hello to everyone in Morocco. Thank you for watching, inshallah. This is the northeastern part of United States, near the Canadian border. This, above this line, this is all Canada. This is Maine, and this is Vermont right here. This little star, that's Topher's parents' old house, where I used to live right on Lake Champlain.
Sweet.
Now this thing crossed over the Lake Champlain, over these the Green Mountains of Vermont is the Green Mountain state, so it passed over the Green Mountains and was seen flying into almost Maine area. So it didn't go that far, but it's probably right around in here somewhere. But there's like no water there, If it was flying towards this area, I'd be more concerned.
How do you guys feel about the 10-pound weight, though? That's not a lot.
Yeah, that's not. I did some research on that because I didn't want to put up facts or things like that without having some way of backing it up. NASA Meteor Watch, what they did is they were able to get the percussions and the sound vibrations and the seismic activity that the Earth returned. So they were able to get the sounds and the energy that the Earth absorbed from those sounds. They know how far it was in the sky above, and they're able to do the math, and they do that math with weight of TNT. So they'll always say the bolide or the meteorite exploded or entered the atmosphere with a force of 40,000 pounds of TNT. So and then when they have that figure, they're able to know the speed and velocity of the meteorite, and through math, they're able to figure out the mass of the object. That's my rudimentary way of describing it.
And of course, they're making a number of assumptions there about density of the meteorite. Meteoroid. It's called a meteoroid until it hits the ground. The light show is a meteor, and when it hits the ground, it's a meteorite. Unless it's a meteor wrong, which happens a lot.
Now, I will interrupt you for a little bit of humor, because there was and I don't know the name of it, but there's a famous meteorite that landed. It's a meteorite, but it never touched Earth because it landed in a hammock.
Oh,
okay.
Wow. Well, yeah, we may have to fine tune the definition for that one.
That was a lazy meteorite.
Yeah. So the how much did it weigh, and especially the question of how much did it ablate? How much mass did it lose coming through the atmosphere? That one is a total wild card, because meteorites go all the way from super hard like an agate to dirt clawed crumbly.
Yeah, just to simplify it even further, imagine an iron meteorite, a hunk of iron. You throw that in the same forces, the same wind shear, the same heat, the same everything as a carbonaceous clay ball. Which one's going to last longer?
Yeah.
And then you can go, those are the extremes. Then go in the middle and look at like a rocky one. I heard a fact one time that 80% of a meteor mass is lost upon entry. Now, there's a lot of variables about what type of meteorite, the angle of approach, the length of burn, all that. But a good rule of thumb, if you start with a basketball entering, you're going to have a softball when you're done. So let's see what else is on the next slide.
If they have seismic information, shouldn't that help narrow down where it possibly landed?
Yes, absolutely. In recent years, a few of the people in our meteorite community have used data from seismometers, and with, in places where there's lots of seismometers, you can triangulate. When they have sources of audio, as long as they are time calibrated well, you can also track the audio itself. But as Topper mentioned, that audio, those sonic booms shake the earth, and so you can do triangulation. Then the other thing too that some of our folks worked out is that you can use weather radar. Weather radar gives you returns on snowflakes and raindrops. So if there's a big rock coming through the atmosphere, you can get a good return on it as well. And that plus
that gives you a lot of the altitude information.
Yes,
that's the Doppler RADAR, right?
Yeah.
And
you would figure the military would have surveillance, thinking that a bolide would look like an incoming missile.
Yeah, but they're not going to say anything.
No, they're not going to share.
That's a whole nother story and a whole nother data set, and we could probably talk for an hour about that one too.
Absolutely.
But with all of the weather data that we have, winds at altitude, direction, winds at the surface, and everything in between, there are some folks in our community who have created models that do a spectacular job of predicting the search areas. Now, that it's nothing like, okay, the GPS coordinates for the main piece of the rock is such and such, and we walk out there and pick it up. But it narrows down the search area and has enhanced the ability to recover these things. And then, of course, the camera networks as well give great data. But the incandescent part of the flight ends at something like 40,000-ish feet elevation. And so you really need those winds at the surface, winds at altitude, and the triangulation for the sonic boom, which happens much lower in the atmosphere. You really need that information to narrow the search area. Yeah. Sorry, Topper, back to you.
Well, no, that's really good. I want to let Roberto know we're going to come to him next, because we're talking about recent witness falls, and Roberto has a surprise to show us. But yeah, the thing that's unique I like about meteorites, the bolide event. When we say a bolide event, what we're talking about, and I'm not going to give any other details, but a bolide event is when a meteor is entering our atmosphere and explodes, breaks apart, ruptures, whatever you want to call it. That is called a bolide event. So you can call it a witness bolide or a bolide, and that usually spreads a bunch of pieces. A very, very, very famous bolide was Chelyabinsk over Russia in 2013. It happened 19 miles over the city. Obviously, the optical, the light, the photons hit our eyeballs, their eyeballs, the sky flashed, everyone went to the windows and was looking out the windows at the smoke vapor left in the sky, oblivious to the fact that this We talked about megatons or tons of TNT that just exploded in the sky above them. That pressure wave is just rushing down on them, and they had no idea. And that's how so many people were injured. They saw the bolide event, went to the windows, and then the windows, 20 seconds later blew in their faces. Bolides can be dangerous events besides extinction events. But there was and I'm not going to talk too much about it because I don't even know. I'm going to kick it over to Roberto because he's going to update us on a different new witnessed fall. Roberto Vargas, everyone. And
everyone.
Friend.
Yeah, this is Charlie.
Hey, Charlie.
He hangs out in my reptile room, so he he's like first responder. If anything gets loose, you'll hear him start squawking, and I know,
Good
so, so I wanted to talk about a meteorite that fell. So we were talking about Winchcombe. Winchcombe fell February 28th, I believe.
Yes.
But a month earlier, on January 28th, a meteorite fell in a small village called Astomulio in the sub-district of Punggur, which is on the Sumatran island of Indonesia. Fun fact: 6 months ago, a meteorite fell in the same island in Sumatra in Indonesia. So it's crazy because Indonesia is a country made up of 1,000 islands. And for the same island to get hit twice in a 6-month period is just like ridiculous.
Wow.
And then for both of those to be hammer falls because
explain what a hammer is.
So a hammer fall is basically a meteorite that hits a man-made object. That's what a hammer stone is. A hammer fall is just a meteorite fall that has a hammer stone or multiple hammer stones attached to it. So in August of last year, 2020, meteorite hit a house in a small village called Satahinali in the sub-district of Kolang on the island of Sumatra. That was a CM12 fall. We were talking about carbonaceous chondrites. We were talking about CM2s and murchisons.
So anytime you hear a meteorite classification that starts with a C, you're talking carbonaceous.
Correct. So that happened in August, and then in January, just 6 months later, another meteorite, like I said, fell in Astomulio, and it hit a house. It was almost the same exact weight. It was 2.2 kilos both times. It hit, like, the outside of the house, fell through the roof and into dirt. So, like, the similarities between the two are kind of crazy.
Mm-hmm.
The only thing is that this is an ordinary chondrite as opposed to Kolang, which was carbonaceous.
So ordinary chondrite means a stony meteorite.
Correct. So and this fall consisted of 5 stones, whereas I think there were 3 stones for Kolang, the main mass, and then 2 much smaller ones. But so we heard about this fall. I heard about it the day after it fell and immediately started working on it. And we tried to work on getting the actual hammerstone, but the hammerstone was, as soon as it hit the house, the owners called the local university. And the local university and the villagers dipped the hammerstone in a fish tank aquarium full of water. Yeah. So supposedly it was to measure like water displacement of meteorites. Like it isn't something you do with meteorites.
We're talking about collecting with aluminum foil. They're fish tanking it.
Yeah, basically. And there were just a lot of problems with that stone. That stone ended up, because of the iron content in it, it ended up rusting almost immediately. We got pictures of it. It looked really bad. And then the university took a large chunk, and then we found out that it was owned by like 9 people. But then we found out that there was a main mass of 2,500 grams. There was a 1.7 kilogram stone. There was a 138 gram stone, and I think a 50 gram stone. So there were 5 stones in total. Another interesting fact. Hold on, let me get this first. Hey, come here.
Roberto, did they have any trouble with the local people thinking the meteorite had spiritual value to it?
Yeah, thanks for reminding me, actually. So after they dunked the meteorite in a fish tank, the local villagers collected the water and distributed it amongst themselves, and were said to have been like drinking it and putting it on themselves, believing it to like have like magical healing properties, and that it was gonna prevent them from catching coronavirus. So,
God.
Yeah.
Well,
yeah. But I sent Topher a couple links to the fall that kind of give you a rundown of it. And I have here, just a second.
Boom.
So this is the 2,500 gram main mass.
Wow.
Yep. If you just give me 1 second, I will throw on some gloves.
This is crazy. This is why I love our group. Like, where else are you going to see one of the freshest meteorites on Earth in private hands?
And boy, this thing's a special one too.
Wow, look at the size of that.
Yeah.
Yeah, look at all of them.
Look at that metal. Look at those metal ribs.
Yeah.
That's fusion crusted metal.
Wow.
That's cool.
Hey, Roberto, is there any way to turn your camera sideways and still go? Or yeah, there you go. That makes it even better for us.
Beautiful.
Wow.
Boy, that one has that conundrum: cut or not cut.
Oh
yeah.
Right.
Well, it's the main mass. Ideally, we don't cut it, but we'll see how it goes.
But
look at the interior of this thing.
Yeah, don't blame you on that.
So yeah, hold on 1 second. Let me just adjust these real quick.
That looks like not an ordinary chondrite, man. Good night.
Wow. A lot of metal in that.
Oh my God.
Remind you of anything?
Are we talking any? That can't be mesosiderite, is it?
No. So as soon as we got it, the first thing we did was like, you know, as we do, we send it out for classification. So we sent it to Dr. Lawrence Garvey at ASU, and he took a look at it, and you know, we had some things that we thought it might be. We were really hoping for like a Winonite. Winonites have been so big lately. And then we were thinking an EH enstatite chondrite. But it came back H melt breccia.
Wow.
Yeah.
So still a great classification.
It's still a really good classification. There are only 27. No, there currently are only 26 approved meteorites with that classification.
Wow.
20 of them are from Antarctica. So really there are only 6. And this is the only witness fall of that kind.
That's amazing. That is fantastic. Let's rewind 12 seconds though.
Yeah.
H6, we're going to talk about that later, okay?
But it's
a melt breccia.
Yeah.
what that tells me is a breccia is a combination of multiple materials, and melt meaning it was shocked or heated to the point where there's liquid in between that's now coalesced, obviously.
And if you look at the size of the other ones that are available in non-Antarctic, not a lot out there. I think there's only one other one out there that's over a kilo. Everything else is like a little 53 gram, 75 gram piece.
Dude, that is
Beautiful.
gorgeous material. Really, really nice.
Yeah, so I have I'm in for half of this, 2/3 of the 1.7, and I think that's all that's really available right now.
Well, that little slice, the tiniest one there, just put a little envelope on it, send it my way, and we'll call it a deal.
Yeah, absolutely.
Congratulations, Roberto. That's an amazing amazing accomplishment, not only for the scientific value of it, but for being able to share it with us collectors. That's gorgeous. That is just so rich with metal sticking out.
And the amount of effort necessary to make these things happen in that part of the world during the times of COVID is pretty extreme.
Yeah, I would have loved to have flown to Bali, and from Bali to Sumatra, and actually been out there and like gone and grabbed it. But I mean, when you have it in your hand, it's just as good. I'm just happy they got to have it, you know.
Wow. Yeah. Dude, would you do me a favor? Send me a really nice high quality, high res picture of the metal veins on that thing. I want to put that on a thumbnail for this video. It's that special.
Absolutely.
Certainly is.
That's crazy beautiful. Oh my God, those rivers of metal are beautiful.
Mm-hmm.
And Roberto, do you know any working provisional name yet?
Punggur.
What is it?
Punggur. Punggur.
Awesome. Thank you very much, man. So
you're welcome. Thank you.
Yeah, dude, that kind of content, man, stop on by any and every week, man. Perfect. That's fantastic. Seeing brand new material that just landed. Let me hit pause for 1 second. We're going to now switch gears into our class session. So it's going to be Meteorites 101. So while we were paused just then, a question was asked by Bruce. Why aluminum foil is used to collect samples versus plastics, and some of the comments were Pat and Michael.
Go ahead, Michael. You're the geologist.
So plastics. Obviously, if you're collecting something like we're talking about that first fall in England, where it's carbonaceous, and they're interested in carbon-based material in there, hydrocarbon contamination from a plastic bag would be something that would be viewed negatively upon. And with the aluminum foil as a good material, aluminum is not an overly common material within meteorites. It is in some of them. Like Pat was chiming in too, it's easy to tell if it's exterior contamination by aluminum foil versus something that was actually in the material.
And I have actually been in at ASU's lab where they're working on specimens for testing, and I guess it's very easy and very convenient to build these little aluminum foil cups, and they can pass them around. They can stack them up. They're pretty easy to work with. So and it's a common household thing that everyone has. So if you tell someone to go out and make sure you pick it up with aluminum foil, odds are they have aluminum foil and they can do that.
Right. Yeah. So the other part of that too was for ANSMAT, where they've got a very, very well developed protocol. They actually use Teflon bags that don't have plasticizers and hydrocarbon nasties inside them. They scratch the information into an aluminum tag and put the rock and the aluminum tag inside of a Teflon bag, and they don't touch the rocks. They use kind of a wire forceps sort of thing to pick them up. If you got the time and infinite resources, Teflon bags. Otherwise, aluminum foil.
Yeah, when we go out hunting, we're not really collecting for scientific purposes. We're hunting like Holbrook and Sacramento Wash and things like that, local to us, and we follow proper protocols as far as GPSing the location, taking in situation pictures to show exactly how it was aligned. And let me highlight Pat for a second.
Yeah, so this is not a self-collected one. I couldn't reach one of those, but yeah, I use Ziploc bags and a Sharpie, and when it's a find, then you write latitude, longitude, time, date, and then you give it some sort of field number. This one obviously is a classified meteorite, but you know, when you're in the field, all of that, you do all of that stuff, and then you take in situ pictures, but you have redundancy because you got it written on the bag too.
Yeah.
Pat,
and
a quick question, please. When you find them in the desert, you'll see videos where people are picking them up with their bare hands. And understandable, what's on the desert floor could have been there for thousands of years. So is it a moot point to think about contamination from your hand, the oils and things in your skin contaminating whatever purity remains in that meteorite?
Yeah, you know, so for things like this is one that I found in Nevada. This thing's been on the ground for thousands of years, and it doesn't hurt to handle it. There's not going to be any groundbreaking science on this. It's an L4 or something. But it's, if you're hunting a fresh fall, you definitely want to take precautions, and especially if you're hunting a carbonaceous fall, because carbonaceous chondrites have a very, very similar physical property as a charcoal briquette or a chunk of charcoal. They can absorb stuff. So
it's funny that you mentioned that, Pat, because that's what one of the homeowner said. The father, when he looked at it at first, he said he thought someone dumped out their barbecue. Yeah. So good information there. Let's see if this works. Boom. Can you guys see Meteorite 101? No, you can't.
No, we still got your others.
So now you should be able to see it. Okay. So now we're going to move into Meteorite 101. Hopefully this, well, not hopefully, this will be. I'm the god here. This will be a reoccurring weekly event where we hopefully can share a little bit of information on a slice of the meteorite science. I'll just give you guys a second to take this in. This is courtesy of the Smithsonian. And what we're looking at here is I'll describe it first, and then anyone can chime in with whatever intelligence they have that I don't, or an easier way to explain it maybe. In the beginning, you see there a bunch of just dust balls, little cosmic dust, little chondrules, little bits of rocks, statically charged and attracted to each other, and they kind of globulate onto each other, and they keep on building up and building up and building up until they form an asteroid. Once that asteroid has enough size, it now has its own minor gravitational pull. That definitely helps add pulling more material on and accreting and making this thing into a bigger space object. Once it gets to a certain size, as we can see in the second picture, you see the center is getting a little bit warm. There's a lot of material in there, and we're talking about hundreds of thousands of years. So there is some radioactive decay of those materials. Radioactive decay generates heat. Heat then melts and liquefies, allowing heavier items to then fall further deeper into the gravitational pull into the core of the planetoid, or planetesimal, I'm told. After that, when you start having the heavier metals kind of liquefy and get pulled towards the center, that leaves a lot of lighter stuff to float up to the surface. And what we see in the final picture, okay, well, in the picture with all the orange, the third picture, you see that heat now affecting the entire planet. you're maybe getting some, or not planetesimal. You're seeing some maybe magmatic flows. You're seeing some volcanic activity. I'm not a geologist, I don't know. But you're definitely getting a mixing of materials at the center, a bunch of metal, near the outside, a bunch of rocks. And that's the final end result. Think of that as like a cross section of planet Earth. We have a liquid metal core, a large mantle that's full of just rocks and minerals and stuff. And right around the edge, we have a crust. So what we're going to focus on just today is the very, 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 very first step. We're not even going to get to the part where it starts getting heated and things start changing. All we're going to talk about is the little cosmic dust balls and little chondrules and all that stuff that gets statically charged and attracted to each other, and then is it accrete a word? It accretes into a larger rock that's now floating out in space. So that's all we're talking about today. We're not even getting to this second step here.
And I'll throw in one word while we're here. And great explanation, spot on. One way to describe just the stuff in the box on the left, the yellow box on the left, is that's an undifferentiated rock, in that it is of its original composition, sort of everything stirred up together in one rock. And then as you move across the page, you get more and more differentiation, where the rock is, the various parts of it are separated out and concentrated. So today we will be talking about undifferentiated meteorite material.
The way they get differentiated is by that heating and the melting and the time and the gravity and all the processes that we described. So Thank you. So yes, we are talking about this yellow box only, which are chondritic stony meteorites. So taking one step back, in the grand scheme of meteorites, if you were to get super simple and say, hey, in vehicles, you have motorcycles, cars, trucks, trains, and buses. In meteorites, you have three main types of meteorites. They are, the first one there, what we're talking about today, chondrites. They're stony. That's all they are, is stone and metals. Then the second type is iron meteorites. Now, these are differentiated because they have gone through this process now, and they are liquefied and made into this core. So the second type of meteorites are differentiated iron meteorites. The third type is a mixture of both these two. It's the stony and the iron mixed together to make a stony iron, sometimes called a palisite. This material is a mixture of the outside crust and the inside core, the liquid metal and the liquid silicates. That only happens at a very, very small patch, a 4% diameter, if you will. 4% of the cross section would be what's called the core mantle barrier, where the mantle and the core mix, and you have the liquid metals and liquid silicates all together. And that's what what composes the three main types. We're not going to talk about this at all today. No chondrites. The three main types of meteorites are stony, iron, and stony iron. We're talking about stonies, chondrites, and those are undifferentiated. They have not gone through any processes. This is a chart that you will be quizzed on, so take note. When this shows you a little bit of the complexity that is involved in true meteoritics. When I say that, if you look up here at the very, very top, it says of all meteorites, 94% of all meteorites fall into either chondrites or achondrites. Well, so 94%, that's practically all meteorites. Practically all meteorites consist of almost practically all chondrites. So we have a crap load, a very, very high percentage of meteorites that fall to Earth are chondrites, are stony, are undifferentiated, and that's all we're talking about today. We'll talk about all these other things as time permits, but right now we're looking at this little box right here. That's all we're discussing. And you'll see it's broken down into three main classes. There's LL, L, and H. And hopefully my numbers on the next slide match these, but now this was actually made by a bunch of our friends. I'm not aware of Tompkins, but David Weir gave me permission to use this today, and Mendy is also a friend who was helped to devise this. We're going to come back to this weekly and highlight different areas. But we were talking about carbonaceous chondrites earlier. Carbonaceous chondrites are right here in red, and as you can see, they represent only 3.6% of the 94%. So less than 3%, about 3% of the meteorites are carbonaceous. And like I said, we're only talking about these right here today. So this is how we go down rabbit holes, because we have all of this stuff and we love talking about it all, and it's kind of hard to stay right on topic. But right now we're going to discuss the differences between the three classes, LL, L, and H. So if this volume's too loud, please let me know.
LL chondrites have the least metal at between 19 and 22% total and between 1 and 3% free metal. This is a witnessed fall, and this is Chelyabinsk. Chelyabinsk fell over Russia, and you can see that there is metal in there, but the quantity is not that high. L-class chondrites have a moderate amount of total metal in the range of 20 to 25%, with 4 to 10% of that metal being free. This is a fantastic witnessed fall classed L3 named Abapanu. Notice at the top of the stone you'll find an armored chondrule. Abapanu is known for having armored chondrules. These are some backscatter electron microscope images of my classification, NWA 12574. The white areas show the metal content. H-class chondrites have a high metal content in the range of 25 to 31% total mass, and about 15 to 19% free metal. This meteorite is Nova 009 and is classified as an H4. This is an example of an H5 melt breccia. This is Tacitus 004. Here's a brief demonstration of magnetism and classifications of meteorites. LL has the least amount of metal, no draw, and hardly enough to keep the magnet on there. L, firmly attached, but a mild shake and the meteorite falls off. H, that's H. That's L, and that's LL.
Okay, so hopefully that information was helpful for you guys. If you want to take a screenshot of, if you want to take a screenshot of these numbers right here, that might be helpful. But Pat, maybe you can hit on something that I didn't touch on in that when I was talking about total metal versus free metal. And I put this up to try to help you.
Yeah, so on the other camera, hopefully you can see me okay, but I've got this for showing meteorites. Yeah, so free metal is in the metallic state, but a lot of the components of meteorites, a lot of the crystalline materials, olivine, for example, will contain iron as well. Olivine has a very unique thing that it has magnesium and it has iron, and those two can substitute for each other. And so one of the chemistry things that we'll talk about in episode 97 of Meteorites 101 is that. But there's iron that you can't see, or metal that you can't see, that is incorporated in the other parts of the meteorite. Yeah, and
I want to ask a question about that because I don't know, and that's what we're here for. We're here for learning. You're telling me that if I can't see the metal, it's not.
I can barely hear you, Topher.
Oh, sorry about that. There we go. I'm going to ask a question because I want to learn myself, and that's what we're here for. When I look at this backscatter electron microscope, we're talking about microns, and I see small little veins of metal. Would that be considered total metal but not free metal because it's not in blobs?
Well, I'm not a geologist, but my understanding is that if it's there in a metallic state and you can see it in a metallic, that is free metal.
Okay, so it's truly a chemistry thing.
Spot me on that, Michael. Is that correct?
Yeah, no, you're correct. If it's tied up in the mineralogy and it's not native metal as far as its content, then yeah, it wouldn't be considered free metal.
Okay.
All right. Thank you.
Thank you.
So now I have a slide showing a few meteorites sliced to show the interior of them. And what we're paying attention to here is the amount of metal first off. So we have an LL, which has basically very little, if not any metal, comparatively. If you go to an L, it has more metal, and you can see there's little flecks of metal all in this one up here where the light's catching it. If I took it at a flat angle like the El Hamami, you'd see more metal flakes in it, but you can see them there at the top, so there is more metal. When you get to the H's like the El Hamami, there's no doubt there's a lot more metal in it.
And there's a continuum here too. Sorry for interrupting, Topper. There's a continuum. Some of these H meteorites, including some of the ones that Topper has shown recently, have spectacular amounts of metal. The free metal is in the 30s or even 40% in surface area on a cut. So this is not quantized. Think about this as a continuum.
Exactly. And with that continuum, there's a different these numbers change. You see there's a 3, a 4, a 5, and a 6. They're in that way for an obvious reason. But what I want to do is also explain when someone like me gives you a classification and I say this meteorite is an LL 3.15 S2 W1/2. You're like, wait a second, you just blew my mind. This is 101, not 202. Okay, let's just back up for a second. We already talked about the LL, so that's super easy. We already know it has low metal. Let's go to this one. This is a little bit easier, okay? This one is an H, so it has heavy metal. It's a 4, meaning the chondrule size, and I'm going to let Pat elaborate on this in a minute. But we're looking at the chondrule sizes. The actual size and shape and roundness of and correct me when I'm wrong, of the chondrules. You'll notice as we go from left to right, it goes from beautiful, pretty, tiny, and small. Buzzard Coulis is just amazingly gorgeous as well. But it shows less organization, less and small round with big matrix around it. Then you go to the H5, you notice that there are chondrules in there. There's one here, there's one here, here, one up here. They're all throughout, but they're definitely not like one of like the 3 or the 4. So as you go up in this second number, whether it's an L, an H, or an LL, the second number talks about the chondrules. So as we go up in that chondrule rating is what I'm calling it. It's not the official term. You see more and more alteration in the chondrules to when you get to the L6, and you are struggling to pick out a few chondrules that are there. There's one right there. They are still present. There's some down here. They're still present, but they're very hard to find. The next step and last step is an L7. Chondrules are obliterated. There's none. Pat?
Yeah, so this is there's a bunch of really good meaty stuff here. So the number there is the $10 name for it is petrological grade, although we just usually call them type 3, type 4, etc. So what happens is everything started out as 3.00. So the numbers go from 3.00 is completely unmetamorphosed, not messed with, very original sort of material. As you go higher and higher in number, there is more modification because of heat and pressure over time, and the grains of minerals in the chondrules actually recrystallize in a solid state form. We're not talking about melting. We're talking about recrystallization, and the materials actually move around. It's pretty amazing. And so 3.00 is as they originally were, and that's characterized, any of the threes are characterized as big chondrules, and the chondrules just cheek by jowl, just all crammed in there together. On this particular one, if you saw this under a microscope with the right lighting and everything, you'd see even in the dark areas there's chondrules. So it's pretty much all chondrules. This type 4, there are a bunch of chondrules there. They're beautiful. They're well defined, but there's a little more space in between them, and that space in between them we call matrix, and that's where the recrystallization is starting. By the time you get to 5, you can see those chondrules are very well separated. There's a lot of matrix in between, so there's a lot of recrystallization that's gone on. The type 6, even more, so more time of higher temperatures and higher pressures, which allow this solid state recrystallization. And then if we had a 7 here, it wouldn't look a whole lot different than this 6. 6s have relic chondrules, as Topper accurately said, and in 7s, I think it's still theoretically possible for there to be a relic chondrule, but it didn't happen very much. And so those silicate materials that form the chondrules have totally recrystallized into other grains. And so we call all of these chondrites because they contain chondrules. And chondrule is a $10 word for little spherical things we find in rock. One of the exciting things about these chondrite meteorites, and Topper's master slide that we'll go back to as we go through these sessions of the classifications, the vast majority of them are chondrites. And so, 85.5% of everything is a chondrite of some sort. Mm-hmm. And when meteorites were first recovered on the ground and cut open, they started looking at them. This is right around the year 1800. They found these weird chondrite stones that were out of context with the rocks around them. And out of context doesn't always mean it fell from the sky, but in this case it does. But the important thing is not only are they unlike the rocks around them, but they're very much like each other. And so we started finding these rocks in all sorts of places around the world, in many different environments, many different geologies, many different topologies. And are these rocks that look the same inside. Topper, I've got some 3.00s to show. Please tell me when.
Yeah, I want to do that during show and tell. I definitely want to see that because I don't have a 3.00. So I wanted to talk about, so we have an understanding of the L's, the H's, and then the 4 behind it. So let's go to the next part of the classification. S2.
Before we move on, can I ask a question?
Please.
Sure. So looking at this slide here, looking at like an L3 in comparison with an L6, where I believe, if I'm thinking correctly, I think it was last week we talked about like pressure fractures. Is it possible, or has a meteorite ever been found that could be an L3 but had an impact significant enough to cause stress fractures? Is that a thing, or is it my scenario here, I guess, is you have this meteorite floating through space and it impacts one other, I guess, asteroid or whatever in space, and that is what deflects it to Earth. Is it possible to have big L3 style chondrites paired with stress fractures from a significant impact?
Yeah, so there's a three things there. Let's tease apart. So
let me interject for 1 second, Pat, because the effect you're talking about is the shock value. So that's what the S2 stands for. This has a shock rating of 2. This has a shock rating of 3. This one, you can definitely see shock veins, and it went through a traumatic experience. So just to finish my thought there, the S was for shock value, and the W is for weathering. How long it's been sitting on the ground. Is it a 1? It goes from 0 to 4. The Buzzer Cooley and Venalis were both witness falls, so they were picked up immediately. They weren't on the ground for 10,000 years. They were on the ground for 10,000 seconds, and therefore their weathering state is 0. And the shock value, excuse me, is what Luke was asking about. So Pat, if you would, please continue with explaining what the S value, the shock value of the classification is.
Right. Okay. Well, without being tempted to go down any rabbit holes, all of the meteorites that we have in our collection, except for the few that are from the moon and Mars, are from our asteroid belt. This is basically leftover material that either didn't form up into planetesimals or formed into planetesimals or planets that were later disrupted and busted up into pieces. And so all of the meteorites that we have here on Earth changed from an orbit in the asteroid belt to an Earth crossing orbit. That generally happens when they run into each other. And sometimes those are kind of like minor fender benders and they just get deflected a little bit in orbit. Sometimes it's a flat out head on. So all meteorites have at least some degree of shock if you look at the whole meteorite. But we use shock 0 to shock 4 to describe that. And what we're really looking at there are shock features like the shock veins in that Venalis that we were looking at. And so then there's one step further called an impact melt, where that collision is so violent that it actually does a huge amount of melting, and the shock veins and the melt veins look black when we look at them in reflected light under an ordinary microscope or just with a naked eye. But what's going on there is those areas have melted and then solidified very rapidly. no time for crystals to grow. And so that material essentially is glass, where it's quite uniform, and so it's glass. So when you look at it in reflected light, and then also when you look at it in reflected cross polarized light, it's black. So shock veins are black. Slicken sides, which are the shock plane looking along that vein, are also black, and the melt rivers are black. So
have you ever seen a highly shocked L3 low petrology?
Yeah,
Okay.
I've not seen a 3.00 or 3.10 or what have you, but yes, they exist.
Okay. So an LL3 can have a shock value of 3. It doesn't matter the chemistry of the item. When it hits something, it's going to react. Pat, I want to see this perfect 3.00. I'm going to highlight you.
Okay, so
these are rare and expensive.
Yes, there are only. I didn't get a chance to look up how many classifications of these.
Pat, I want to interject for 1 second because I want to make sure everyone understands what we're talking about. You can show it off while I talk if you don't mind. We say that there's L3, L4, L5, but what we're talking about now is jeez.
Wow. I'm drooling.
Hey, and Topher, LL 3.00 NWA 10061. If you look it up, that's a shock stage 3 as an LL 3.00. So yeah, they can get pretty highly shocked.
This one has a shock value of 3 as well.
Yeah, and still be LL 3.0, because the L 3.00 is talking about the chemistry of like the olivine inside of the chondrules, versus what the shock is in there. So even though I got shocked and thrown off, the chondrules themselves haven't been altered. You got to figure they're classifying off of 20 grams, right, off of what could be kilos of material. So what you find in that 20 grams sometimes is like trying to figure out what you have if you're touching different parts of the elephant,
Yeah.
And you only get the trunk or you only get the foot.
Right.
I appreciate it, guys. Thank you for answering that.
Yeah.
No problem. And one thing that we're when you have something as beautiful and pristine and unaltered as that, you're not just satisfied with a scientist saying it's L3. The next thing is, because that's the type, the next thing is subtyping, meaning diving into it. We know it's an LL or an L3, but it's a 3 point what? That 3.00 versus a 3.1 makes a huge difference in price and value.
Right. So what we're looking at here again, this 3.00 this is a different one. This is NWA 8576. So what we're looking at is how metamorphosed, how changed the chondrules are with heat and pressure over time. And the way, as Mike was mentioning, the way we determine these subtypes of the type 3s is by looking at how the chromites have migrated in this solid state recrystallization and solid state migration of material around inside the rock. The first thing that moves are the chromites, and a group of meteoriticists, including Grossman, did this work and found correlation between how primitive they were, how unmetamorphosed they were, and how the chromites have moved. So that's kind of the first step in them moving. So this is.
I've heard the term primitive. I'm going to talk over you because I want people to talk over me.
Yeah, we're having trouble hearing you, Topher.
Sorry, I'm going to talk over you because I want people to talk over me at will.
No worries.
You use the word primitive. Could you please explain that?
Yes. So primitive, I'm using here as just being very, very undifferentiated, very, very, very unchanged as original. As the materials is as unchanged as possible.
Okay, thank you.
and so these are
beautiful, by the way.
Yeah, thanks. These are available, kind of. This one, 12,693 or 692. The total in weight is only 373 grams. These are in the, when you can find them, they're in the $300-ish a gram sort of range. But they're very interesting to me because they really are the original stuff. So all of our chondrite meteorites started out as very unmetamorphosed, and as these little chondrules, these little balls of material, of silicate material, and we'll get into chondrule formation in one of these sessions, but they kind of glom together and form up into rocks, and the deeper they get buried, and the more sources of heat, so there's your heat and your pressure, then they get changed, and so a type 3 will turn into a type 4, which with enough time at temperature and pressure will turn into a type 5, et cetera, and each of them, their development is halted at some point in the process when they get down to lower temperatures, and instead of banging around in the universe, they're pampered in our collections.
Oh my God, dude.
So this one I've chosen because it just really shows the chondrules very nicely. And apologies for this camera. This stupid thing's got too much noise, and that's a little better.
I have go ahead.
Yes, go for it, Topper.
My question is this. It only seems logical based on what I said earlier that as something gets bigger, it generates more heat, more reaction, more metamorphosis.
Yes.
Would it be accurate statement to say that all 3 point X's, all primitive chondrites are going to be smaller than larger meteorites?
That is generally true, yes. So there's less chance for heating, and that heating, there's really two big sources, and you touched on them. One are fairly short-lived energetic radionuclides. The most significant one is aluminum-26, which provides a lot of heating, and if you got a smaller rock, that heat can dissipate way easier without affecting the rock. And then the other part of that is impact heating, where a body will gain more mass by things slamming into it at 25,000 miles an hour and up. And so those things all contribute to heating, and with a smaller mass, they're less likely. That's not to say that all small meteorites are type 3s.
Yeah, I wish.
they were once upon a time. By the way, not as a commercial plug, but this material is material that is soon headed to classification by Mr. Stephen Amara.
Yeah, Stephen Amara from Space Matter.
Yes. So that's a beauty. And then I've got one more. So this one from Stephen Amara that I showed, this one we don't know the classification yet, but so Stephen and I think that this has a pretty good chance of going low, so being 3.x or even 3.xx.
And that subtyping is an expensive add-on to normal classification services, just for everyone's information.
Yes, that's correct. The lab work to spend the extra microprobe time, the lab work is adds on $300-ish or so, because what you have to do is go and measure the chromite level in a number of different grains inside a number of different chondrules, and so it adds to the microprobe time. And then this last one that I'll show here is another unclassified
CV
chondrite. So, well, yeah, this one. So that's a very interesting comment, Topper. The carbonaceous chondrites, especially the CVs, and the very primitive, the very unmetamorphosed type 3 chondrites have some strange overlap. Like type 3 ordinary chondrites can contain CAIs in some cases. You'll get chondrules with glass. You'll get with glass in the chondrule, you'll get trollite, more trollite, a bunch of interesting stuff there. But so this one, again, you know, by magnetic attraction, we know is an LL, and then by looking at the chondrule size, we can estimate that it's LL.
That's fantastic.
And
awesome.
On the part of the video where you talked about testing for how strong the magnet attracts, you want to have one magnet, which is your standard. Usually I have one at my fingertips.
Yeah.
That's yours. Here it is. Your standard magnet. And so, you know, I know this one is an N52 grade magnet. I bought 50 or 100 of these. They're all the same. Yeah, it's a not niobium, but
neodymium.
Neodymium. Thank you, Topher. Magnet, and there are different grades. This is N52. This is the highest grade neodymium magnet, so the highest.
And what Pat's saying there is really, really important, because if you're going to be trying to do your own scientific tests to try to figure out what you have to use the same magnet each and every time, so you get that same expected result. And that way you know exactly what you're doing. We're going to hit pause for 1 second. All right, we are switching gears into Mars, and Mike Kelly has something to show us.
Yeah, so we've been talking a lot about the Perseverance and the target detector for SHERLOC on there, which has that piece of SAO 008 on it. So one thing that's interesting, if you look up SAO 008, it has a sister set of stones found on the same date, a little over, I believe it was 2 kilometers away. And that would be SAO 005. So it's genetically tested to be the exact same material as what was sent back to Mars. And
that's pretty cool.
Of course, if you find that out, you want to go find a piece of it.
Nice. Oh, what a display.
Cool.
So I went ahead and found someone who had some SAO 005, and it's a really cool looking stone. So those really dark pieces are olivine megacrys inside of a pigeonite kind of ground mass. So you see, you know, it didn't get much, not that much of it out there, but I went ahead and put together a nice little display box for it.
If you're making background noise, can you please pause yourself? Mike, I have no problem plugging other dealers and resellers. Who'd you get that from? Do you mind?
Sure, that came from Eric Dwelker. That's meteorites.com.
Okay.
I believe his website. I'll check to make sure that site's right. I know it's Eric.
I appreciate I appreciate that packaging. That's care.
Yeah, and so that was a background that we came up with. So it just got the piece. And,
you worked with him on that?
No, I just made that. That was I just got the piece and put that together myself.
Oh, that's your background.
Yeah.
Oh, good job. Okay.
That's
all
brilliant.
Right. Well, forget about Eric then. I was worried more about the design in case.
Yeah, that was the other background, and those were you know, that's you know, I'll give credit where credit is due. That's off of an image off of space.com when we were talking about you know, that target detector. I went ahead and looked it up, and I thought that was really great.
You'll be seeing that up close in about 2 minutes. Thank you very much. That's really cool. I love the packaging you did on that, man.
Nice
Thank you
job,
so much.
Mike.
Yeah.
Well, Cameron's face, nice.
This is Cameron Smith. What do you have there, buddy?
Mike Kelly was kind enough to tell me that Eric Twelker had 2 pieces.
Oh.
Ah.
You know what you need to do now is ask Mike to send you that other stock card that he had, and you can make your own display easy now.
There's one already in the mail.
Yeah, he's such an awesome guy. It's actually already on its way.
Nice.
That is what the community is about. That's beautiful, man.
Absolutely.
God, that's awesome. So that's actually the one that NASA is pointing their their sensors at in order to calibrate. Is that what we were?
Yeah, that's one of the calibration targets for the pixel instrument that we talked about briefly last time.
All right. So hopefully you guys can see this now.
Yep.
Hide that. Okay, so we're now on to Mars, and to follow exactly, I mean, like he knows where I'm going. I just, if you're making noise in the back, could you please mute yourself? One of the great things about space and about this hobby and meteorites and science is science are nerds and they love hiding things and playing games. And there's really a lot of background noise. I'm not sure who it is, but it's quite annoying. Maybe it's Stephen Amara, perhaps. We're good now, thank you. So this is the SHERLOC calibration panel that's actually on Mars right now. And there are Easter eggs hidden all over this thing. And I had fun with it. So I'll show you what I did. There's the maze. I solved the maze. It's not hard, but you got to take the time and do it. So if you look right here, there's the maze. And if you go online and it's an Easter egg, I'm not going to tell you where it is. You got to go and find it yourself, find a high quality res picture of that, and you can claim that you solved it too. But you don't get a free Topher Spin magnifying glass. This is another Easter egg that we all pretty much know about by now. One of the chips on there. We'll go back to the panel and show the panel. So we're looking down here at this right here, the 221B Baker, and that is actually the made-up address of Sherlock Holmes Detective Agency that's no longer in business. So that's another cool little hidden thing because this is SHERLOC, the device, so they're using SHERLOC. Now, I'm not going to give you the answer to this next Easter egg, although I'm going to give you everything you need to do screen grabs to figure it out yourself. One of these words is extremely important. SHERLOC calibration test geocaching trackable marker. Right below it, what are we looking at? A bunch of dancing guys. What the heck are those? Well, in the Adventures of the Dancing Man, Sherlock Holmes is given a piece of paper in the beginning of the mystery, and all it has on it is these stick figures. And he has to figure out and crack the code using frequency analysis. And is he able to save Elsie's life? Dum, dum, dum. The note that he was handed, he decoded to say, Elsie, prepare to meet thy God. But if you look at the geocaching trackable marker, that's not what it says. It says something else. Well, here's a hint. No one say anything. No one say anything. There's a lot going on in that picture. Well, I'll tell you what. Does anyone? What do we know? Let's try to figure it out. Can anyone recognize anyone in that picture? Or the people in the background give a really big hint, and so does the constellation. All right, we're gonna have to do you guys can do a screenshot and figure it out yourself. Here is the Dancing Man decipher. So you can use this decipher and go back to here and figure out why I included that picture. And tell me who those people are, and you've solved it. Stay tuned for more updates. We're running kind of long today, so we're just going to move right on. But there's all kinds of fun things to do online regarding space. Like I have my boarding pass to go to the moon already. You know, I went to Mars and I booked my next flight to Mars. Well, if you go to dearmoon.earth, you can pre-register and get your crew member boarding pass as well. We are into space exploration here, and next weekend I will be accompanying my good friend Oz Bachman at the Spring Blast 2021. I've never ever been to a real model rocket. I don't know if they're called model rockets at this, but they're freaking enormous rockets, and they're going to be launching a bunch of them. This is the instrument panel that he had to build by himself. I mean, we're talking some pretty serious stuff going on, and I'm pretty excited to participate in this for the first time. Here's my buddy Oz right there. He's going to launch. This isn't the rocket he's going to launch, but he's going to get like 10,000 feet.
4, 3, 2,
at
1,
Mach
launch.
0.8.
Mercy.
That thing disappeared, didn't it?
Mercy.
I mean, that thing just disappeared.
4, 3, 2, 1, launch.
Now this next video is even crazier. This is Oz next to his own built rocket.
Mercy.
And this is Oz flying said rocket. And guys, if you have a hobby that you think is interesting and relates to our topic, by all means, talk to me about it and let's put it up. Look at that thing. I'm so excited for next weekend. This is his. Look at that. He's hoping to achieve at least 10,000 feet, but he's told me unofficially he'd like to get 12.5. He has altimeters, GPS, all kinds of stuff on it. Oh, Oz, you're with us today, aren't you?
Oh yeah. That was my level 3 flight in 2008. That rocket weighed 75 pounds. $70 a second to fly that.
$70 a second to fly that thing. That's pretty crazy, man.
Yeah, you don't even get a meteorite.
No, you don't get it. So that's where I'm going to be next weekend. And as a team, as a crew, we have achieved a major milestone. We now have 1,000 members, subscribers to the channel, and that's just crazy. I thank you all for your support. And some interesting, I love stats. So I just thought I'd share some stats with you guys. Behind the scenes, Topher, Spin, the Knowledge, Bolide, only 28% of the hours watched are from subscribers. 70% of the people out there are watching but not subscribing. Don't know why wouldn't you subscribe? Everyone right now, subscribe and hit the like button. That way YouTube pops us up a little bit and more people can find us. If you look at this list over here, this is a list of all the countries that currently view us. There's 36 countries, I think, that view us. Average age is about 35 to 40 years old. And if you look at the beginning of the channel a year ago, it has just been a constant level of growth. So really happy with what's going on and the weekly participation with all my friends. It's fantastic. So in that year, the most viral video I had 6,000 views. So I mean, we're talking about crushing numbers here, but 6,000 views. And that was the video I showed you guys today with the meteorite magnetism. And you can see this is the normal performance of videos. What, 500 views? This is this one, 6,000. But this is what's shocking. This is the video I am most proud of. And it only has 1/5 the views. If you watch another video on my channel, I would recommend you search for this. This is the actual title of it right here. We mentioned Dr. Lawrence Garvey earlier today. Excuse me. Dr. Lawrence Garvey is a friend of mine, and he is the curator of ASU's Center for Meteorite Studies collection. They have one of the largest academic collections, and it's just phenomenal. He heard of our hangouts, heard of how enthusiastic of collectors we are. He's an extremely passionate man. That's why we gel so well. It's extremely passionate. And he gave us a 2-hour private inside tour in the vault where we could point to anything and he'd pick it up and explain it to us. And he would get down rabbit hole and get so excited. He would put this one down and go over there and get this one. And wait, let me put these all back for a second. It's a great video, a lot of knowledge, a super smart man, and a place that most humans will never step foot. I highly, highly recommend you go and watch that video. So let's move on. With that being said, I am very excited to mention and let you guys know that on 3/27, on Saturday the 27th, I'm having a live meteorite sale. It should be about 3 hours long. The last one was 4 hours long. Hey, I have meteorites and you have wallets. So it should make a good combination.
But not so long.
But in all honesty, it's going to be a great time because I'm having a new meteorite enthusiast help me out run the sale on the backside. Chris Monk, who was in our group the last week or 2 weeks.
Oh,
yeah, he bought the oriented ones for me. He came over a few days ago. We spent a few hours together, and he's going to come back and help me run the sale. And I promised him he would leave with more rocks in his pocket than he came with. my money's no good with him, so he's going to be helping me. And that reminds me, I want to show you guys something. I don't know if can you see that wooden logo back there?
No.
My wooden logo back there. That was a gift from him. He showed up with this. One of his friends has a woodworking shop, and they made me a wood logo. I think it's just phenomenal and ultra cool. So thank you very much, Chris Monk. And I cannot wait for you and I to crush that sale together and just have a great time.
What time are you planning the sale?
In Arizona, it's going to start at 4 o'clock. So that's 4 o'clock Mountain Standard Time.
It's going to either be like 6 or 7 here in New York.
Yeah, if you
kind of sucks because that's actually the start of Passover.
Oh, I'll tell you what though, not everything sells right away. I'll put the video up on YouTube, and if stuff is left over, you can definitely tell me that you want something, and I'll extend the discount to you. No problem, Bruce.
I appreciate that.
Yeah, it's never a problem. We're checking in now with Marko. And I think he needs a haircut personally, but so here we go, Marko. I know when this first screen pops up, he looks mad. He's not.
Hello, everyone.
Sure does.
I hope you're all doing good and you have a fantastic hangout today. Yeah, I prepared a very interesting shaped meteorite today. To be honest, I'm not really sure if it is oriented. And come on, let's have a look on it and maybe you can give me your opinions. Yeah, here we go. That's my unusual piece. It's a 1.2 kilogram unclassified NWA chondrite. And I think the shape of this meteorite is really, really interesting because I'm going to stop the rotation here. First, what is really interesting is that the piece shows these, I don't know how to call them, are they regmaglyphs?
Like fluted regmaglyphs.
Yep.
Yeah.
But also
yeah, those are
on this side.
Definitely.
And they're all aligned.
But what is interesting here.
Okay, yeah, they were all going the same way. Is that what you're saying, Pat?
Yes.
All pointing in the, yeah. Okay.
Right.
But what is interesting here on that side, the piece shows a rollover lip. And if I turn it around, so
there's flow lines.
Here we don't have a rollover lip. Yeah, isn't that weird that the piece shows here on both sides elongated regmaglyphs,
like
also these aerodynamic form, but on the bottom you won't find any rollover lip. But here, I think, yeah, to be honest, I will not call this piece oriented. For sure it is flight marked, and I'm really sure that this piece had a very interesting flight history.
very unique.
Yeah, so we can learn a little bit about that. The orientation is not a 1 or a 0. It's not either it's oriented or it's not oriented. There's a continuum of orientation. Furthermore, it is common in a lot of the Socotilene meteorites for them to have a few stable positions and sort of be multi-oriented. And so you'll see rollover lips in different places. You'll see rollover lips that don't really align with the rest of the stuff. But this meteorite oriented in a couple of different directions on its passage through the atmosphere.
This right here goes along with the fluting. So this would be the leading edge, which means this would be the shearing side, but you have the back rollover lip. So eventually at one point in time, it was going in this direction from here to there, but in the same time, it was also going this way. So it could have been coming diagonally, and that would account for both things at the same time.
Yeah, so I think the aligned parallel regmaglyphs, and I would definitely call them regmaglyphs, what's happening there is the plasma that is traveling through is swirling. So those are little vortices, and they excavate out the regmaglyphs, and you know, they're all parallel. So obviously it was traveling in that direction for quite some time. And that was probably the earlier orientation direction. And then here we're looking at the backside of it, finding another stable oriented flight direction, flight orientation.
But this was tumbling at a point, and then it straightened itself out and took on a trajectory in which it sort of oriented itself.
Well, I from the number of flight markings on this one, I would say this one probably didn't spend a whole lot of time tumbling, because remember that incandescent part of the flight is pretty short.
Yeah.
But I think it oriented with the top up, the top as being the forward face, and those parallel regmaglyphs developing down the sides, and then it flipped so that we're looking at the backside.
And that orientation is just when it enters the Earth's atmosphere, correct?
It's only during the incandescent part of the flight. That's the only time you get regmaglyphs forming, and when you get the surface of the rock molten and flowing.
Now, this may just be total hypothesis, and we'll move on, but what if it was oriented in flight, creating these flutes, these fluted regmaglyphs, until enough material was ablated away and it shifted orientation and maintained an oriented flight in another. I mean, we weren't there, we'll never know, but it's nice to play Sherlock Holmes, to little callback there, to try to figure out exactly, you know, the history of your stone.
Right, we can infer from the physical physical part of it, we can infer what happened.
Hopefully we didn't go back too far.
Yeah, to be honest, I will not call this piece. It is flight marked, and I'm really sure that this piece had a very interesting flight history.
Agree with you, buddy. Send it back, it's missing a corner.
Send it to my house.
Yeah, it still has some nice surface texture.
Oh, yes.
It looks like the fin of a shark. Yeah, guys, what are your opinions? Do you agree? Flight marked, oriented? Difficult to say.
Orientations,
but not tumbling.
Yeah, I would definitely say multi-oriented. So, you know, remember that you know, when we were talking a bit ago, we talked about, you know, basketball size to softball size, and certainly as a meteorite is traveling in an oriented direction, and I would argue that those elongated parallel regmaglyphs formed first, because you can kind of see there's some some modification over the top of that, and the edges of them are not super crisp. And this thing is sandblasted too, just like virtually all of our meteorites out of the Sahara. But I would say that those parallel regmaglyphs formed first, and as you're ablating from basketball size to softball size, you're losing a lot of material. When you're in oriented flight, it selectively removes material from certain places, and it can change the shape of the stone so that it's no longer stable in the initial oriented configuration or oriented flight direction, and twist around and reorient in another direction. And sometime we could talk about it with the scodolines, but you'll find lots and lots of evidence of them of orienting in multiple different directions. Amazing stone.
Yeah,
absolutely.
Highly desirable.
Yeah, guys, that is the piece that I wanted to show today. It's really interesting to find such unusual pieces, where it is not clear how that piece formed, or the shape formed of such a piece. Yeah, again, I want to close and end my video with a nice impression of our universe. Last Saturday we had a fantastic clear night, and I was able to catch some extraterrestrial photons. So have fun at the hangout, and again, enjoy the beauty of our universe. Bye bye, guys. See you next week.
See you, Marko. Thank you, buddy.
Yeah, last Saturday was one of those few crystal clear nights of the year. You can see here my setup under the constellation of Orion, and the scope is pointing into the direction of Monoceros, so the constellation Unicorn.
Didn't know there was one.
That's awesome.
Wow.
5,200 light years away in constellation Monoceros, we will find this wonderful, fantastic object. It's the Rosette Nebula. It's an open star cluster surrounded by hydrogen alpha gas. The stars brings that gas to shine, and that's why you can see that red color of the hydrogen. It's really one of the most wonderful objects out there.
Besides you, Marko. Man, that's gorgeous.
Beautiful capture.
Yeah. Man, I surround myself with very intelligent people. Man.
He definitely has a passion.
Yeah, no doubt, man. That's awesome. Well, I'll tell you what, we are going to go through a little wormhole. We're going to go to Ganymede by way of a little wormhole through Brussels. So, Maxime, if you would please be our tour guide to the liquid, I guess, because I'm seeing a bunch of water here. So tell us about Ganymede.
Today we're heading to the giant of our solar system, Jupiter, or to be correct, one of its Galilean moons. The moon we are going to visit today is the largest of the solar system, being larger than Mercury itself. It is also a frozen moon, with a surface looking like a vast ice ocean, dotted with craters and ridges. Also, this is the only moon of the solar system on which you may observe polar auroras. So maybe you have guessed it, we are going to talk about Ganymede. Ganymede was officially discovered by Galileo in the year 1610, when he decided to point his telescope toward Jupiter. He described what he thought were stars around Jupiter, until the following night when he reiterated his experiment and discovered that two stars had moved. He concluded that those were bodies orbiting around Jupiter, and called them Medicean stars, in honor of the Medici family. However, Chinese astronomical records report that Ganymede, a Chinese astronomer, had observed Jupiter's moon with naked eye in 365 BC, what is possible but only under exceptional circumstances. So Ganymede is the third Galilean satellite of Jupiter. It has a diameter of 5,268 kilometers, making it the largest moon in our solar system, being even larger than the smallest planet of our solar system, Mercury. However, Ganymede's mass is only about the half of Mercury's one, indicating that Ganymede is probably composed of about 50% of rocks and 50% of ice. Let's first focus on the surface. Globally, the surface of Ganymede is mainly composed of ice, CO2 and SO2, which is brought by the volcanism on Io, another moon of Jupiter. Many other components are found, such as sulfuric acids, organic compounds, and some salts. When you observe Ganymede, you directly notice the presence of two distinct kinds of surfaces, the dark regions and the bright regions. Dark regions are older and show a high crater density. They appear to be less icy and are composed of clays and organic materials such as tholin, which is one of the most abundant organic compound in the solar system, considered to give the reddish-brownish color of Pluto or other Jovian satellites. These craters are thought to date from a late bombardment that occurred 3.5 to 4 billion years ago. Light regions appear to be much more icier. They show less craters, but a lot of grooves and ridges. They are considered slightly younger than the dark regions. The groove terrain formation is still a mystery for science, but is probably due to tectonic activity, itself due to tidal heating events. To understand that, let's quickly talk about a particular mechanism called orbital resonancy. The idea is that you cannot orbit Jupiter or any other body as you want. In some cases, you won't have a stable position, simply because you will suffer from other bodies' attractions. You should find a stable point or stable orbit. One of the causes of unstable orbits is orbital resonancy. Orbital resonancy occurs when two or more objects' orbital periods are related by a ratio of small integers. In this case, they will interact with each other and create resonancy, meaning that forces will act on each other and cumulate to eventually lead to more unstable situations, where the bodies will see their orbit change until there is no resonancy anymore. However, in some cases, this resonance system remains totally stable, meaning that the mechanics behind the orbits are perfectly as they should be to let the bodies where they are. This is called mean motion resonancy, or MMR. We only know a few examples of MMR in our solar system, 5 to be precise, concerns planets and moons, but many more concerns asteroids. What interests us here is the fact that the three inner Galilean satellites of Jupiter, Io, Europa and Ganymede, are in orbital resonancy, or more precisely in a 1-to-4 resonancy, meaning that for each revolution of Ganymede, Europa makes 2 revolutions and Io makes 4. Now you may ask why I explain all of that, and in fact it is thought that the tectonic activity that caused the apparitions of grooves on Ganymede was itself caused by the tidal heating, itself caused by the unstable orbital resonance in which Ganymede was before being in its current position. So now that we've talked about the exterior side of Ganymede, let's talk of what is inside, and it is even more exciting. If you dug into Ganymede icy surface, it would take you some time to reach the next layer. It is estimated that the upper ice crust is a few hundreds kilometers thick. If you manage to dig deep enough though, you'll find yourself in an extremely deep liquid saltwater subsurface ocean, of a bit less than 100 kilometers deep. To give you an idea, the deepest point in our oceans is at a bit less than 11 kilometers. So needless to say that Ganymede contains much more water than all of our earthly oceans. The presence of such an ocean was confirmed by scientists observing auroras on Ganymede. Indeed, the large amount of water disturbs the magnetic field of the moon, and thus disturbs the auroras you may observe on Ganymede. And that is how we know there is an ocean under the surface of Ganymede and how deep it probably is. Even more impressive now, recent studies taking the various salts present on Ganymede into account have shown that instead of having one large deep ocean, there is a possibility of a multi-layered ocean to be there, consisting of different salinity oceans, each one separated by a layer of some kind of crystalline ice. Ice 1, for example, is the one we know here on Earth, the one we use in our glasses. The following are different, more compact ice forms. That sounds totally surreal. Imagine being in the bottom of an ocean, breaking what you could think is the ground, just to find another full ocean right beneath you. That is absolutely mind-blowing. And furthermore, this study shows that there may be a layer in which there is some kind of snow in the water due to ice crystals, but this snow is going up. So that means that you could have the impression it is snowing upside down. That is crazy. Following that theory, the true bottom of that planetary ocean would be liquid water in contact with rock from the mantle. We know that here on Earth, such contacts lead to the apparition of hydrothermal vents, leading to a proliferation of life due to the large amounts of minerals present there. But if life loves such environment here on Earth, why wouldn't it be the case on Ganymede? We could imagine some life forms such as what we have here in our oceans that just evolved in the bottom of Ganymede's ocean and have never seen the sky. To get better insights on that, one should weigh the launch of the European Space Agency's JUICE mission on June 9, 2022. The JUICE spacecraft for Jupiter Icy Moon Explorer will travel during 7 years, performing 3 Earth flybys, 1 Venus flyby, and 1 Mars flyby before orbiting Jupiter during 3 years and studying the icy moons, Europa, Ganymede, and Callisto.
Wow. You know how much math they must do for that?
No kidding.
After that, it will perform some maneuvers and start orbiting Ganymede, becoming the first ever spacecraft to orbit another moon than ours. Lastly, as meteorites lover, here are some information that are related to the stones we have in our shelves. Rocks in Ganymede are thought to be close in composition to the one of LLL chondrites. Also, a recent Japanese study analyzed the furrows distribution on Ganymede and put into evidence that they may be somewhat aligned and just related to a single event, which could be the impact of a massive 300 kilometers large body going at a speed of 20 kilometers per second. You can see here an animation of the surface during the event. Imagine the amount of mass ejected during such event. Anyway, if that is true, then you could find on Ganymede the largest impact crater known in the solar system, with a mind-blowing diameter of 7,800 kilometers. Needless to say that Ganymede is a record breaker. That is what such size represents here on Earth. So that's it, we've now seen a big part of what is known about Ganymede, and it makes no doubt that there is still plenty of mysteries hidden deep in the ices of Ganymede we still need to discover. Hopefully we have a mission leaving next year that will probably help us understand Jupiter's icy moons way better. To conclude, there are no doubts Ganymede is a unique moon in our solar system by its size, physical properties, and unique internal structure. And we'll probably talk a lot about it in the next 10 years when results from JUICE will arrive here on Earth.
Wow.
That's it for today, guys. I hope you enjoyed the video about Ganymede. And also, I wanted to wish you a great hangout this week, guys. And see you next week live.
Oh, right on.
Well,
wow. That was probably
awesome.
the best production I have ever seen by an amateur. Are you kidding me?
Huge science content in that one, too.
He's an amazing dude.
Wow.
Speechless.
I am just absolutely blown away. Maxime, you nailed that. Everyone, do not be intimidated. I do not expect that of you. That's like PBS, public broadcasting stuff, man. Dude, I'm going to ask his permission if I can just post that video to my channel as it is. That was stellar. Thank you so much, buddy. Look forward to having you next week.
Today we're here.
Real quick, we got to talk about the ugly now. We're talking about now, keep in mind, I'm saying that there's scamming going on eBay, but I'm calling these people fakers. I am not calling them scammers. I'm not calling them thieves. I'm not calling them anything other than what they are. They're putting up fake information. This guy says that he's had his thing analyzed. I asked by whom. He's unable to answer that. I let him know that you're going to be highlighted in this week's eBay Faker of the Week. I'm giving the opportunity to remove all your Mars. We're going to rip you to shreds and laugh our butts off. So yeah, this is the guy right here. Take a screenshot. Texas Medi-2. Feel free to send him a message if you look at his items. But we're looking over here at a piece of high silicon Martian stony iron meteorite. There is no such thing as a stony iron from Mars, and if it has high silicon, it means it was analyzed. But he says he had it analyzed and researched, and part of that research was looking through thousands of pictures dozens of times. So yeah, this is the world's first stony iron Martian, and he had it analyzed but refuses to give any information about the analysis.
Yeah.
He has 100% positive feedback on all 4 suckers that he probably sold crap to. Again, he heard it. Anytime you hear stories, you can probably assume that it may not be real. I heard heavy rains. It is indicative but not proof of a previous, I guess, wet red planet due to its silicon content. He is talking out of his ass. I have spent almost 4 years researching, analyzing, and looking at thousands of pictures many times over. I can assure you this is from Mars. Well, I'll tell you what, Mr. Texas Medi-2, Faker of the Week, congratulations on being Faker of the Week. Let me tell you how to save yourself 4 years and thousands of pictures. You hire a lab, you spend the money, and you get the scientific data. So if anyone asks me for analysis, when I say I had this analyzed, I had it certified, this is the kind of stuff I'm going to give you by Dr. Tony Irving himself, talking about my meteorite with backscatter electron microscope. And other times, this is not, I did not pay for this test. This is not mine. This is just a sample of a communication where sample was sent to the lab. And we're talking about Washington University, right, Pat, in Seattle.
University of Washington. There's another big Washington University that also does meteorite stuff.
University of Washington.
Yes,
and this is Dr. Tony Irving. He is one of the head classifiers of meteorites. So you can send material and he can visually consistent with this. Now, when a scientist of his stature tells me that he did some optical work on it and it appears visually consistent with that, you know, that is better than a guy who says he's looked at thousands of pictures dozens of times. Okay. we ran a little long today, but everything was important and I wasn't going to leave any of it out, especially that Ganymede. Sorry, guys. I just had to throw that one in. Yeah.
Well, another excellent hangout, Topper. Thank you.
I'm trying to stop screen share. Let me pause real quick. All right, awesome. Yeah, so a little humor with Ferris Bueller there.
Yeah, thank you, Topper, for another amazing hangout. Thank you for hosting us. This is best couple of hours in my week, and really appreciate you giving us a forum to talk about our total geeky content here. And I am thrilled that we're doing the Meteoritics 101, and we don't want there to be any barriers to people joining us in this wonderful science. And it can be enjoyed in many different ways, from very aesthetic angles to total geek out science.
Yeah, and that's the goal. That's really why I'm rolling out the Meteorite 101, just so everyone knows. I don't have a PhD. I'm not a geochemist. I graduated high school. That's it. Okay. I held my first meteorite 3 years ago and 3 months. Okay. I'm completely self-taught, and I surround myself with intelligent people who are passionate about learning. And like everyone on the screen who shows up every single week to learn, to educate, to share, to laugh and share stories, I can't thank you enough. So really, Pat, I appreciate you thanking me. Rubber, it sticks to you. I appreciate everyone showing up each week and supporting and asking and learning. So
yeah, I really get a lot out of these. It's nice to focus on something else, especially with everything else that's been going on, and just to learn and absorb all this. It's like I only started collecting maybe 4 years ago, and the amount of information that I've been able to learn from these hangouts is just incredible. And Topher, if you didn't notice in the chat, Mike Kelly posted a link to an article on classification.
Okay.
And I think that should be important that you can include in your description.
Perfect. Thank you. Yeah, I definitely appreciate that. Anytime you guys want to show something off, throw it in the chat, and we'll get it out there as well. I'll make sure it gets into the summary. But everyone, thank you very much. We didn't have much at all show and tell today. Trust me, I have enough stuff to show and tell. I want to do it too. So next week we're going to do Meteorite 101. And we're going to focus on showing off stuff. And Arthur, we're going to go to you first, okay? Because you've had your hand up this whole time, and I'm super sorry. You've had it up the whole. In fact, I'm putting your hand down right now. Sorry, we don't have time. Have a great week, everyone. Take care, guys.
Yep.
Bye.
Bye,
Good
everybody.
night, it's over. Good night, everyone.
Good night. See you, Alex. See you, Cameron. Oz. Safe launch, buddy.
Guys.
Bye.
Good week, everybody.
Thank you.